This is the Tesoro AI podcast with Darius Gant. AI is changing the world and fast. This episode is coming to you courtesy of Tesoro AI, the #1 recruiting service for software development and AI talent.
All right, and Omar, welcome to the show. We appreciate you taking some time out to join us.
Hey, Darius, happy to be with you.
Absolutely, absolutely. So, would love for you to give folks some context into your background, and if I can call it this, kind of your professional career transition into, this AI ecosystem.
Yeah, sure, gladly. So my name's Omar. I lead the product team at Brainbox AI. I've been here for about 4.5 years now. My whole career has been in the, let's call it the smart building sector. So things like building automation, lighting control, heating and cooling controls, system integration, and so on. The way that I got into this space is kind of interesting. So essentially, I've been working for about 20 years in this domain, and I live in Montreal, right?
Mm-hmm.
That's also where Brainbox is headquartered. And when you live in Montreal, you hear a lot about AI. So the reason is because one of the, let's say, the three fathers, as they're known, of AI, a professor at the University of Montreal by the name of Bengio, is kind of located here as well. So his research going back to the 80s is really what spawned kind of a big AI ecosystem in Montreal. So at some point, I think around 2016, I'm like, okay, time out. I've had enough about hearing about this AI thing, and I don't know what it is. So I need to spend some time and learn about it. So I did a certificate in AI and actually got to look under the hood. And that, gave me, it was kind of a light bulb moment where I realized that, my goodness, there's a really good fit for AI technology in buildings. And we'll talk about that later on in the show. So once I got my training wheels off, then, and the opportunity with Brainbox came along, I jumped at it because I felt this is the best way to kind of make the AI world and the building technology world merge.
Yeah, interesting. And so you mentioned kind of, this certification process, or maybe it's incorrect, but was it a certification, or did you actually kind of go back to do some sort of master's in?
Sure, happy to elaborate. It's actually a certificate. You can find it on my LinkedIn. It's by deeplearning.ai. So this is the Andrew Ng, built course for deep learning. So it's about 5 courses that you take, and has kind of exercises and exams and so on. And it kind of walks you through all the different components that you need to understand deep learning.
Okay. Yeah, I actually took, is it the same one that's offered through Stanford?
That's right. And Coursera.
Yeah.
He's a prolific guy. Yeah.
Yeah, I took that during the pandemic, and I remember banging my head up against the wall that I didn't pay more attention in statistics.
Yeah, you and me both. There was a lot of, let's take a look at this again, but it helps, right? It helps us kind of stay nimble.
Absolutely. Yeah, I remember when I was in Columbia Business School, I was like, I'm never going to use statistics. Why am I in this class? And then here I am sitting down looking at these matrix math, and I'm like, geez, okay, shoot myself in the foot.
That's right. And then had to learn some Python and some TensorFlow. Yeah, it's good to get the juices flowing.
Yep. So just, talking about the work that you do with Brainbox, would love to understand more about this pain point that Brainbox is solving and not just the pain point, but historically, how has it been solved, whether that be something manual or whether we even use traditional software?
Really great, I would say, start to our conversation. So when we look at a building, right? The building can have different purposes, school, office, etc., and it has occupants and so on, different schedules. The building has needs. So to simplify, you need to heat it and cool it and ventilate it. That's what HVAC systems do. You need to provide lighting, and you need to provide kind of plug loads. This is a kind of a high-level overview. There are some corner cases. So when we started installing heating and cooling systems in buildings, the need to control them and control comfort came along. And that's where we saw, and everyone probably has seen, kind of thermostats on the wall that help us kind of control temperature and so on.
Right.
And so there's a whole world of building automation systems that vary from the very manual, where you just go up to the thermostat and you change the temperature you want, all the way up to sophisticated networked systems that are sold by major companies like Honeywell and Johnson Controls that allow us to control HVAC systems in a large, let's say, high-rise tower. And these systems are, it's kind of interesting. And that's kind of what my background is in these building automation systems, is they're typically client server architecture. So there's a server somewhere in the building that
Okay.
hosts the software and the database and so on, and is talking to the sensor in room one, in room two, and say, okay, it's 75 degrees over here, etc. And this data gets aggregated in a database in that computer, and it typically lasts for a month, 6 months, depending on how it was programmed. And then it gets overwritten because of size issues and management issues.
Right.
So that data kind of is generated, is very valuable, but doesn't get utilized that much. And that's really unfortunate because it's a perfect fit for AI, as you know. So AI is a data hungry kind of world. And this type of data that provides space temperature, outside air temperature, supply air temperature, the fan status, the cooling status, we can do so many things with these data points. So how it's been managed so far historically is that these building automation systems, you come to the computer that's in the building, in the basement or the mechanical room, often you log into this software. It's typically a thick client, so it's a software that's installed on that machine.
Okay.
And you have a graphical UI and you say, okay, I want to change the temperature in room 101.
Right.
Cool. Click instead. The challenge here is that there's a lot of information that is very valuable to running this building that is absent here. Example, I would say 95+% of the building automation systems out there don't even know the cost of electricity that they consume.
Okay.
So is this 10 cents per kilowatt hour? Is it 25 cents like in California? They don't know the grid emissions factor. They don't know the occupancy status. They don't know. So there's a lot of information that would inform how I run my building
Right.
that is not available. So all this to say is that these client server architectures work and they work well, right? So the buildings are conditioned and so on. But it's this opportunity that's now being driven by kind of the market to provide better energy efficiency, lower emissions profile, lower maintenance costs, that is driving the need to liberate and democratize that data.
Yeah. Do you have any examples, just to kind of make it more concrete, some of the ways that, building owners or folks who are managing buildings can then use some of this data to make one thing, like what may be a scenario? Is it that, oh, we have on the west wing of the building, no one's working. We don't necessarily need it to be 75 degrees there, right? I'm just curious what kind of things that people are, what are folks doing to actually to see that actual ROI or benefit?
Yeah, so you have a variety of tools. So typically people will use something called a building schedule. So they'll say, well, my building, people walk in at 8 in the morning, so I need it to be at my set point at 72 degrees at 8 a.m. And they usually leave around 6 p.m. And so I need it to go back to its unoccupied mode at 6 p.m. And that unoccupied mode would be, let's say, in the summer, a higher temperature. So maybe I can let my zone drift up to 80 degrees because there's nobody there. So I don't need to spend unnecessary energy in cooling the space. So these tools are often implemented at the commissioning stage of the building when that system is installed and everything checks out, everything's working well. The
Right.
challenge is that what we see in the market is known as the building drift.
Okay.
So you commission the building, everything is good. And then as time goes on, as users use the system, different micro changes are added to the system. So, oh, I'm going to override the set point over here. Oh, I'm going to force this fan on because somebody's complaining. Or, oh, the schedule over here. So these micro changes aggregate and they create this infamous building drift. What is drift? It's a building that is drifted from its commissioned state and is now a lot less efficient than it could be. And the only way to solve this problem kind of programmatically is to have some sort of a software that will continuously observe and continuously check, why did that move? Is that a temporary move or a permanent move? And do I need it? And should I bring it back to its commissioned state? So that's kind of the summary of how these things are navigated today. So there's a lot of manual work required in what is known as the retro commissioning of a building. So there are firms you can hire. They'll send people to your building. They'll take a look at the system's design and they say, oh, well, we can do 1, 2, 3, 4 to bring it back. But it's a very costly and manual intervention, as you can imagine.
Yeah, yeah. And so you got, and you alluded to the data, all the different types of data that are being stored, and ultimately they last for a month, as you mentioned, and then they're gone. But it's AI that is able to use the data. What is it specifically, though, that the AI is allowing us to do over and above calling, some of these consulting groups who send people over to fix things, or just generally speaking? I don't want to get it specific to that particular solution, but like,
Sure.
what is the AI doing here?
So there's a very important set of outcomes that one gets when we digitize a building. First, we normalize the data. So the data right now, you bought a system from vendor A. That vendor's technician, when they installed the system, might have called a specific point supply underscore air underscore temp, or they could have said SAT. Right? So there are different naming conventions. There's no standard naming convention. So normalizing the data to a standard naming convention is step one in liberating and democratizing that data for it to be consumed by other applications. That's step one in the Brainbox process.
So when
Step
you say
two,
that means just, if we have a bunch of different names for the same thing, we may not necessarily associate the data.
That's right.
We may not necessarily say this particular set of data is relevant to all of these different names because it's kind of segmented.
Exactly. So I might not know, algorithmically or from a software perspective, what the context of this data point is. It a supply air temperature, a space temperature sensor? So contextualizing and normalizing that data is a kind of unheralded hero of the process because it makes everything visible.
Got it.
Then I can consume, right? So I'm an application, I can consume that information and I know what this point means, what it is. And that step then leads to an AI training step. So what happens then is the AI can consume that data. So it says, well, the space temperature in the office is 75 degrees, 72 degrees, and so on. So what we do is we train the AI on how to predict space temperature in every zone of the building 2 hours in advance with over 95% accuracy, given the outside air conditions and weather. So the AI actually goes and fetches that weather station. Usually it's within 5 miles of the building based on the latitude and longitude. Then we know, well, it's 80 degrees and humid outside. It's 72 in Darius's office. So this training period gives that predictive ability to the AI. So now, great. So I know that in 2 hours, Darius's office is going to be at, let's say, 75 degrees. So what? So what that gives me is now the ability to act.
Right.
So what's unique, and you asked the important question, Darius, which is, what does the AI do? We'll take that prediction and say, okay, well, Darius's office is going to be 75 degrees in a couple of hours. Well, I don't want it to be 75. My set point is 72. So I don't want to go up and then back down. That's wasted energy. So what do I do now? Well, I'm going to turn the fan on right now. I know you don't want to, building, because you're not aware of the future, right?
Right.
You are a reactive control system. So I'm going to, using my prediction, I'm going to turn the fan on now, and I'm going to stay at 72. And I'm going to avoid that wasted energy that we described. So that set of optimizations is done at a micro level, at the zone level, so at Darius's office or at a specific air handling unit or rooftop unit. And it's done 24/7, 365. And it's the aggregation of these micro optimizations that generates really meaningful savings for our customers. So our customers benefit from up to 25% reduction in their HVAC energy consumption. That gives you two home runs: utility cost reduction and greenhouse gas emissions reductions, that they come together. So very powerful, I would say, start to the AI digitization journey. And maybe we can talk here in a bit about what other applications we have for the maintenance side after having spoken about the energy side.
Yeah. No, I mean, actually, because, we're in that section of the episode, but on the maintenance side, what are some of the applications of AI that are useful?
So, when we talked about normalizing the data, right, and getting that data into the system, think of a technician. So I'm going to talk about one of our customers who they have essentially two, what they call priority one work orders, right?
Okay.
It's one of them is, let's say the space temperature is above 78 degrees for more than 4 hours, they need to send a technician to that site and fix the problem right away within 24 hours. So think of the technician that drives to that building. They roll into the parking lot. All they know is that there Tuesday afternoon, there was a period where it was higher than 78 degrees for 4 hours.
Uh-huh.
All right. So think of now the what I call CSI HVAC. You have to go and investigate
Figure out
and
what-
follow the trail of crumbs. Say, okay, well, it was hot here. This is a ductwork coming from this air handler. Go to that air handler, check that fan. So this sequence of deductive logic is required to troubleshoot the event. So what AI can do here is it can collapse that time on site for the technician and reduce their cognitive load that's associated with the ticket. For example, we released our ARIA, which is our virtual building assistant. It's the world's first virtual building assistant.
Uh-huh.
And ARIA can be spoken to on a text or voice interface from your phone. So I can say, hey, ARIA, I'm in the parking lot of this building. Why was there a comfort complaint last Tuesday afternoon? Well, it seems that the supply air is reading above this and the fan is off. Therefore, you should investigate this particular unit. And okay, Aria, what type of unit is it, by the way? Oh, well, it's a Carrier, make, model number, this one. Okay, what type of parts does it have? So you can see how just access to data is giving you kind of a lot of efficiency. So to summarize the value that it can bring, so it can fetch me data.
Mm-hmm.
So what is the temperature in this office? It can analyze data. Why was it hot last Tuesday? And it can act on my behalf. So I can say, hey, Aria, it's a snow day in Boston. Please put all of my Boston buildings into unoccupied mode.
Got it.
Because I don't want to spend any unnecessary energy. So it'll go and execute that command. So very powerful for facilities professionals that are managing these buildings the world round.
Yeah, and I imagine it kind of, you take it to the point where, let's say someone is querying the system for, an issue that they've identified, that has been called out. Obviously, at that point, there's some manual labor needed, but at least when they arrive at the site, they're going to save some time because they know where to go, or are at least directionally correct in terms of how they're going to solve the issue.
Absolutely. Absolutely. Many use cases that come with that. So there's also from the CapEx planning side. So we see a lot of facility managers that are asked annually by, their teammates. So, okay, so what units do I need to replace next year? How much is it going to cost, et cetera? So ARIA can crunch through all of the asset registry that you have, and it can identify those units that are in need of replacement based on either their age or their cost of operations, and serve that up to you as a list. So again, collapsing that time that it would take to crunch through lots of information to produce these reports.
Now, is this primarily for like commercial real estate, or is this also applicable to residential?
It's a great question. So we are specialized in the commercial building space. So that includes office, retail, mall, airports, schools, many different types of buildings. We haven't ventured into residential and industrial yet, but I would say there's a very kind of large kind of need to be served on the building side. Buildings emit 38% of global emissions. And so there's a very large kind of problem that needs addressing here globally. We're well on our way. So we're in over 13,000 buildings, over 17 countries, many different cities and many different types of buildings, many different types of control systems, and let's say HVAC types of equipment.
Okay, interesting. I want to talk a little bit about the data, right? I think from the perspective of, if I was a large real estate company that had, a bunch of buildings that I could just use my own data. As a startup, it's a little bit different. What was your starting point in terms of just even acquiring the data so you could then train your AI models?
It's actually a part of our business, right? So it's a significant step is to integrate, to your point, with the existing building automation system. So the challenge here, as you can imagine, is there are many different manufacturers, many different versions of even the same manufacturer's software. So what we've built is a department and a software tooling that enables us to connect. So either the connection is done via an edge gateway, or in many cases via a software driver. So you just install a driver on your building automation system and it dials out through the internet to our cloud. A third option is what we do with our OEM customers. So our OEM customers like Train, for example, private label and resell our solution in the market to their customers under their brand. So it's called Train Autonomous Controls,
Okay.
powered by Brainbox AI. This integration is done on a cloud to cloud basis. So there's no need to go to any location. There's no need to install anything. It's really the Brainbox cloud talking to the Train cloud and
Yeah.
then connecting down through the Train infrastructure to their customers' buildings. And so we have a variety of options that allow us to very quickly and very cost effectively obtain that information.
Yeah. And is there any issue, right? Because you did mention that their data, building data gets stored on their servers, on the customer's servers, but then it's gone after a month. As you think about, the AI needing to use that data, does that create any issues for you, or have you all figured out, okay, well, we can be the solution for that?
You're preaching to the converted, as they say. So we actually are solving that problem. So instead of the data being lost after a month because of the size of the memory on the computer on site, we're actually streaming the data to our cloud. Every 5 minutes, we are taking that value and recording it in the normalized state that we talked about.
Mhm.
And it's the customer's data stored in perpetuity. So we're actually aggregating very valuable data sets over time of how the building is behaving, how the equipment is behaving, the energy consumption, and so on.
Yeah, and one of the things, from what I've seen in terms of, I think this is more true on the enterprise side, but folks are more hesitant to, especially as we talk about application of generative AI, use their data, because it's kind of, all right, well, from a security standpoint, there could be some issues. There could also be issues when someone queries the system, it's sending back data, or I should say a response to that prompt that, is data that they don't necessarily want that particular, in this case, technician to see. Have you guys experienced that, and curious kind of what kind of customer conversations you've had that may have gotten customers more comfortable, or maybe some things that you're still working through from that perspective?
Great question, and it speaks directly to ARIA, right? So ARIA is again virtual building assistant that has LLM conversational capabilities included in it. And the way we've gone about addressing I think the very important points that you're raising is as follows. So firstly, the data always remains the customer's data and never gets disseminated or shared with any LLM vendor or provider. It always remains within the Brainbox environment and is subject to management by the customer. So if the customer at some point down the line wants us to delete that information, that's their privilege, and we will always respect that. We're only using it to deliver our service. So that's number one. Number two, you hit on role or user-based access. So we have a user management system that enables us to kind of narrow down and funnel either the locations that a certain user can see or communicate with. So building A, building B, could be a region, etc. So, or it could be defined by privileges like read only, read write, and so on. So very granular kind of user management system that extends to ARIA. And then the other thing that is important is that there's a problem of hallucinations
Right.
in LLMs.
Yeah.
There's also a problem of different answer on a different day to the same question. So what we've done here in order to get around that is we're merging the Brainbox existing algorithms that we know are working properly. So for example, if I know that there's a fault in this air handler because of an engineering rule that I have written, I don't need to ask the LLM. I know it's wrong. What I need is I need to tie that endpoint in our cloud architecture to ARIA. And that's what we've done. So ARIA has access to the engineering driven rules
Okay.
that give it kind of certainty on how to answer technical questions related to the building. It also has access to this integrated data stream that connects down to the building automation system.
Mm-hmm.
That's why you can ask ARIA to change the set point in your Boston buildings, but you can't ask that of ChatGPT because ChatGPT simply doesn't have the connectivity to go and tunnel down into those buildings.
Right, right. What is it, what does it take to build something like, I mean, I'm specifically referring to the tech talent, right? You've actually got, you got a ton of data, right, that you're pulling in from your customers, but the data is unique to a specific demographic or a specific industry. I don't know that a data scientist is always going to know about data that is specific to building management, right? Nor when you're building an algorithm, right? Do you need ML engineers who have a specific understanding of this particular industry? I'm just curious what it looked like for you to kind of bring together the technical team to actually build a product within this space.
Super important question, and it really speaks to I guess, the construction of our team at Brainbox. So we're about 185 professionals in general, and the team is comprised of what we would humbly say is a first in class, first in industry composition. So we have experts in HVAC equipment design and maintenance and commissioning, control systems commissioning and integration, energy efficiency and optimization, AI. So you need
Mhm.
somebody that knows how to build AI models, data scientists, cloud software development and operations. And so you can see how all of this under one umbrella is necessary to make these applications sing. What we see often in the market is kind of one or the other. We see people that have very strong AI capabilities, but don't know much about the built environment and heating and cooling.
Mhm.
Or the reverse. You see people that know heating and cooling like nobody's business, but they don't have access to the AI talent and resources on the cloud software development side to make kind of those things work together. And so that's how we've gone about solving that problem at Brainbox, is make sure that under one umbrella, we have the right people to be able to build these applications.
Right. And how does that actually, great, you got these functional experts or subject matter experts in their space. How does it work? So I'm getting this client data, right? I'm the data scientist, I'm getting this client data. But ultimately we want to get this prediction about the building that is correct, but I don't necessarily like, I don't know what that means. Now is that where you bring in someone who is a specialist in HVAC to work side by side with the data scientists, to figure out, all right, well, here's the proper label that's applied.
Spot on. So our think of it as a team of teams. So we have folks that are specialized in getting the data out of the building, normalizing the data, training the AI,
Mhm.
deploying the autonomous algorithms that will actually write back from the cloud and say, turn the fan on, turn the fan off. People that are on the cloud ops side that are making sure that all our software applications are running properly. We also have a monitoring team that is monitoring all of our customers' buildings worldwide 24/7 to make sure that we're delivering our service in the right way, the right SLAs that we commit to.
Yeah.
And we also have a measurement and verification team that basically delivers energy savings reports to our customers. So these are different sets of experts,
Right.
each having kind of a unique set or mix of skills that all together kind of create this set of AI or suite of AI applications.
Yeah. One of the interesting, and it's still an interesting challenge for folks building AI products is just, being able to acquire the right talent. So historically, it's kind of been there's been a big challenge in just trying to compete with big tech, right, to get those folks. Now, I think things have changed a little bit with some of the layoffs and whatnot, but still, there's still these, hiring. You still have to think about whether, someone with big tech experience is more valuable, someone with research experience is more valuable, someone with startup experience is more valuable. I guess, as you think about how you all have thought about hiring for your AI team, are there specific best practices or even profiles that you found to be more suitable for Brainbox specifically?
Really, again, spot on question. So I would say first, we're privileged in the sense that we are in Montreal, like I said, and there's a
Right.
fair sized ecosystem here for us to kind of source from. I can see how folks that are in our companies or in other locations don't have that access. I would say the second point is our mission, right? So our mission is to save the planet with AI and to use AI technologies in the fight against climate change. That's what drives a lot of the people. So if you grab let's say a random brain boxer and say, why are you here? They're going to look you straight in the eye and they're going to say, I'm here because I want to decarbonize the built environment. we actually even get held to task as executives by our teammates. Well, how many buildings have we decarbonized this month? So
Mm,
very strong ethos, right, as it relates to coming to Brainbox. And what we've seen from the human resources side is people leaving jobs that are sometimes more lucrative
right.
and coming to Brainbox specifically for that mission-driven purpose. And what we hire for, you ask me kind of what are we looking for? Of course, we need to identify people that have the functional talent, right, and the skill sets and experience. But what we're hiring for above all is culture, right? People need to be aligned on why we are doing what we're doing, and everything else flows from there. So we found that to be a strong recipe for us because it kind of harmonizes all of these different teams and work streams that we have going on.
Yeah, and maybe this might be a tougher question because it's more specific. So feel free to not know the answer. But I feel like in the space where you're looking at folks who are the technicians, the technical folks like the data scientists, like the machine learning engineer that know how to do the work. Because they're so challenging to hire today, it's easy to just say, hey, look, just bring the person on. Right? I don't know if that's you guys' issue, right? You did mention you're kind of in a favorable position in Montreal. But I wanted to ask about the cultural fit question. Within the AI team, are there specific things culturally that need to be in place or things that, culturally, maybe someone who you thought was great technically did not work out?
Yeah, we're kind of happy to say that we're not perfect. So we've had our missteps like everybody else, and we try to learn from the experiences that didn't work out, and we always try to make sure to maintain this culture of, again, mission driven and but respecting people and understanding that we are a collection of people. After all, we're working on AI, but
Yeah.
we are a collection of people, and basically when we find that there's no fit, we just shake hands and part ways, but we stay on good terms with all of the people. We actually even have had employees, believe it or not, more than one, that left to join another company, came back 6 months or 12 months later, said, "Oh my God, I can't take that. I need to come back here." So that's kind of the spirit with which we take this. I think, again, alignment on company culture is so important, right? It just makes everybody understand why we're here and how we're going to go about doing it.
Yeah. Interesting. That I think the cultural element is particularly important, especially because building AI products requires so much more collaboration, right? I just can't tuck you into the corner. Like to the point you were making, you got to work with all of these other stakeholders. I can't just tuck you into the corner and say, hey, build this.
That's right. And maybe I can share a story around this that's
Yeah.
kind of interesting is that, we had an example of in a building early on where imagine a store in a mall and we were connected to the store, right? So we didn't know anything about the mall's environment. And it was minus 40 degrees outside in Montreal, so very cold in the winter. And one of our engineers looking at the site said, "Sees the heating is off. Heating's off, but the store is comfortable." So out of a sense of maybe erring on the side of caution, he said, "You know what? I'm just going to go." So he went to the store.
Hmm.
And what he found was interesting. He found that the doors of the store were stuck open and the mall was heating the store. And essentially the AI had detected that implicitly. It just said, well, I just don't need to be on, right? It's already comfortable. Something else is heating the store.
Right.
And therefore, I'm going to turn the heating off and save that energy for the store. So that's a great example of how the data side needed the context of kind of the mechanical or building science in order to explain and interpret the data. But that's kind of one example of how our teams collaborate when thinking about AI scientists, data scientists, mechanical engineers, energy
Yeah.
efficiency experts. You need all of them in order to deliver these solutions.
Yeah. That's actually interesting because that kind of speaks to curiosity around the kind of practical application of the solution, right? Like it's one thing for me to build it, but like I need to let me get in and feel what's happening so that I can actually have some more context. What's and I don't know that you all have raised funding, but if you have, what's the funding journey been like for you?
Oh, sure. So it's, publicly, I guess, public knowledge that we've raised over 85 million US in investment funds over our life. And it's basically been to initially to build and pilot our technology and then to scale it. So now we're well along the scale up, let's say, route.
Yeah.
Like I mentioned, roughly 13,000, actually closer to 14,000 buildings connected to our platform. And in many different countries, many different climates, zones, and many different types of buildings. Some of our investors include companies like ABB, the government of Quebec. We also have our OEM partners like Train and ABB that, again, private label and resell our solution into the market. So we're fortunate to have a strong set of investors and a strong set of customers and partners to kind of accompany us on our journey.
Yeah, I'm curious if you've experienced any difference in the maybe the questions that ask, the investors ask, the amount of diligence they're doing specifically around the AI as you move from, hey, we're a pre-seed to seed to Series A, right? If things have changed from the perspective of your interactions with investors.
I mean, we have the classical questions that one would expect, when you're earlier on in your journey, people are more
Yeah,
interested in the technology risk and, is it working? Can you show me? And are there any references you can provide? And then once we move into scale, it's about, scale. So how many buildings can you add? And what
yeah,
is the type of customer that you're going after, market segment, TAM, and so on. So that I would say is more run of the mill. What we've
right.
seen, though, that I think is worth talking about here for a second is we've been fortunate to have really two tailwinds simultaneously.
Okay.
One is the AI tailwind, and
Uh-huh.
the other is the climate tech tailwind. And what we're hearing a lot from investors is, when investing in climate tech, there's a lot in, let's say, smart mobility, self-driving car. There's a lot in agriculture. There's a lot in kind of the other climate tech sectors. But when you look at the built environment,
Right.
given that it's 38% of global emissions, very few solutions that actually have impact. We've had investors tell us, there are a lot of dashboards out there. An autonomous solution that can actually affect change, that can actually reduce the emissions of a building, very hard to find. So we've been fortunate again to benefit from those tailwinds, and that's essentially helped us be so far kind of unaffected by let's say, the significant reduction in VC investment that happened over the last couple of years,
Yeah. And for you
more
all,
broadly.
yeah, you kind of rescale, you've got some customers, you're at a point now where the metrics matter. Those are the primary things folks are going to be looking at. Has the fact that you are AI native been a major driving force, and have investors become more educated in the questions that they ask around you being an AI? Because at some point everyone's like, hey, look, we're an AI startup, no matter whether they actually are or not is another question. But I'm just curious, from an investor perspective, have you seen any differences?
Yeah, definitely. I mean, there's definitely, to your point, kind of a plethora of AI labeled companies and startups in the market. And investors are getting savvy around the questions that they need to ask in order to determine, let's say, what's your AI, competency or depth. So they ask things like, well, what does your AI actually do? What does it predict? What's your proprietary IP? Are you just private labeling Chat GPT? And there's another question that we got, right? But I
Yeah,
understand if I was them, I'd be asking the same thing. And so these types of questions are telling us that it's no longer enough to call yourself AI. You actually have to demonstrate what the benefits and business level outcomes are
right.
and how that relates to the investment thesis. So I think that's where, again, the investors are able to separate the wheat from the chaff.
Yeah, it's been interesting because when we first started this podcast, most investors had no clue what questions to ask around AI, right? And then the ones who are really educated would usually had some specific thesis around AI investments. Their fund was dedicated to AI. So they were really great at asking questions. So there was just this huge gap. But I think folks who were not as educated are coming along slowly, because now I think virtually every venture capitalist has a strategy around investing in AI. One of the interesting trends I've seen is, especially if we think about like the LMs, I was reading a post around someone mentioning that they compared the productivity of an LLM parsing resumes compared to someone who had built in their own algorithm to parse resumes, using the LLM was much more effective. And so now you've got, all right, well, we can pay $20 a month for this LLM, or we could buy this point solution that's going to cost way more. And it's, but just thinking through, all right, well, do we actually have a product that has can an LLM just do what we do, right? Like, huge thing. You guys are kind of in a differentiated space, fortunately.
I think you're spot on. I mean, the disruptive nature of this technology is so obvious that you can imagine many different point solutions or softwares that can either now, or have to compete, let's say, head to head with an LLM, or maybe even are underperforming. And then it's just going to grow as the AI models get stronger, as more information is fed to train them. Maybe one trend that we're seeing that's worth mentioning is the trend of virtual assistants and specialized LLMs. So you have the big general LLMs like ChatGPT that everyone is familiar with that can answer, any question under the sun. They're not able to access either certain data sets
Right.
for training or for action. So a good example is ARIA that we talked about, but you can imagine how if I have a specific data set around nursing or around accounting or plumbing, that I can generate a lot of value by merging the LLM's, let's say, broad capabilities and conversational capabilities with my unique data set and knowledge.
Mm-hmm.
And we're seeing that market of basically specialized assistance starting to really crystallize, and investment flowing to these agents, the specialized agents. Why? Because the value is crystallized and clear.
Right.
You don't have to worry about evaluating, all these different use cases. You're focused on one specific one.
Right, right. And I know we're coming up on time here, but I did want to leave a few minutes. We talked about ARIA, but was there anything else, anything that's coming up that you would like to make an announcement? It could be ARIA, but it could be anything else that you feel you want to announce to the public before we get out of here.
So ARIA is something that we're super excited about. Again, ARIA is the world's first virtual building assistant. It can enable all facilities professionals to talk to their buildings. In summary, it can fetch data. So ARIA, what's the temperature in my office? It can analyze buildings. So ARIA, what's the most urgent alarm I need to look after in my facility today? And it can act on my behalf. So I can say, ARIA, put all my buildings in the Boston area into the unoccupied state because it's a snow day today. Super exciting. We also just announced today, which is our case study with Loyola University in Chicago, where with the Center for the Built Environment out of Berkeley, we were able to reduce their carbon emissions by over 10% using our autonomous AI technology. So go take a look at that case study. It's a great example of how what we talked about, which is the leveraging of AI and building technology, can drive meaningful reductions in emissions and help in that fight against climate change, all without turning a screw in that building. It was just better control, AI doing a better job than the existing state. So go check it out. It's on our social media and LinkedIn pages.
Awesome. Yeah, we'll have to get the links on the episode description as well. But Omar, this has been great. I appreciate you letting us take such a deep dive into what you guys are building with Brainbox, and also educating us on the built environment. Definitely an interesting vertical where, to your point, we're starting to see AI be able to make a meaningful impact.
Really appreciate your time, Darius, and having us on the show, and enjoyed the conversation as well. Wish you and your viewers a great day.
Absolutely.